Zorana Milošević. I'm from Technical University of Madrid. We are coordinators of AIRSHIP project, and I will cover a little bit what we are doing during this project. It's a very tangible one. We are actually building something, not just some digital models. This is the scale model of the plane ship that we are building. We have already a couple of small ones, 2 meters wingspan. By the end of the project, we will have a 5 meters wingspan. I will give you this so you can touch it and see it's real. About myself, yes, so my background is in automation and robotics. I'm from Belgrade, from Serbia. After that, I studied in Madrid University, and now conveniently, I also work part-time in Finland. So a lot of traveling around. And I've been working on underwater robotics and as well in some mining robots, and now in these flying ones. AIRSHIP project, autonomous flying ships for inter-island and inland water transport. We are a low TRL project, well, mid, not very low, but we are aiming to level 4 to 5. 5 million budget, 48 months. We are now in 2 years and a half. We are finishing the end of the next year. We have 7 partners, a lot of universities, so a lot of research done. From Madrid, we have 2 different research centers. I'm from Center of Automation and Robotics. We have also Center of Industrial Electronics. We are developing the autonomy, autonomous guidance, navigation, and control. Our partners are developing the power plant. Tampere University in Finland, they are the one designing this plane that you are seeing now. Taltech University from Estonia, building the business cases and running all the social environmental analysis. University of Luxembourg, working on the AI control. La Palma Research Center, my colleague Arish is here on dissemination and communication and exploitation activities. Inestec Research Center from Portugal, they are working on situational awareness and perception, very needed for the autonomous vehicle, and a small company from Trisolaris from Azores. What are the main objectives of our project? So first, we want to build this vehicle and to lay a foundation for a new class of vehicles, what we named the Unmanned Wing-in-ground Vehicle, so just another acronym. It's a fully electric and unmanned system. In order to accomplish that, we have quite a few of technological challenges on the road that we are tackling a little bit during this project. We are not going to solve most probably none of them, but we are getting there. The crucial one is to have a stable flight. Very low altitude stable flight is far away from trivial. I will come to that also later. To accomplish that, we need advanced control algorithms. We are working on traditional control, reinforcement technique control, AI, obstacle avoidance, situational awareness. All the sensors that we need for that are very limited due to the weight. When we have a flying vehicle, any gram matters, so we cannot put all the possible sensors. And then very important, the power plant, full electrical power plant. We are also researching on having the solar panels and fuel cells, so we can also generate some energy while we are working. Then, after we solve the technological challenges, we need to see who wants to pay for this. And those are the business models come there, where we are comparing our technology to the current ways of transport, which is the shipping, railway, aviation, obviously, and trying to estimate the potential profit and economical viability of this technology. And of course, the legal aspects. Sustainability, checking of the researching on the social impact and environmental impact this can make. And of course, to raise the awareness and to educate the people, the general public about this technology, which is not so known. This is the model of our plane, which we are going to have next year. Very short history about the Econoplans. They're called, Econoplan was the name used in the Soviet Union. They're ground effect vehicles. This is not something that we invented. This is ground effect is a natural phenomenon. You will see later in one small short video. The concept was found or first discovered by one Finnish engineer in the 1930s. So that's why I later moved to Finland, naturally. And then during the Cold War, it was heavily researched by the Soviets for slightly different use, because what they discovered was that if they fly this close to the ground, it's very difficult to detect this vehicle with traditional means. So they wanted to exploit that. This was the biggest ever ground effect vehicle which was built. It had the maximum takeoff weight of 500 tons. It was quite huge. And however, most of those projects, they were stopped, discontinued for many different reasons. One of them was that the difficulty to control it and to fly it. The pilots who were flying the ground effect vehicle, they were experiencing very big difficulties and mental effort to keep this low altitude flight over a long time. So that's why we got the idea of doing it autonomously, removing the human from, not keeping the human in the loop, but moving it from the pilot position. So this is the video, can you please? This is the example of the ground effect in nature, what animals are obviously already using, exploiting. That we can see a bird, which when it's flying in the ground effect is basically not waving the wings at all, and it's just gliding over the surface. When it gets out of it, then it starts waving the wings. So this is just the example of, now we can see the same thing happening. So this is the effect, the natural phenomenon that we are trying to exploit with these vehicles. Thank you. What basically means when that while flying close to ground effect happens while flying to any flat surface, we are operating over the water, so we're talking over the water surface, but it happens anywhere on the ground, on the ice. When flying very close, the wing vortices which happens, they don't develop as much as in the higher altitude, and which in the end creates something that some people say increased lift. That's not apparently so clear. Is it increased lift or just decreased drag? But it's basically lift to drag ratio is higher compared to flying in high altitude, which means using less power and being able to take bigger payload in the craft. Very short explanation of this ground effect. The main specs of it is, so we are operating close to the surface. Our main selling point is that we can move faster than the conventional, the ship, and also we can take more payload than the airplane. So we are in some sweet spot between those two means of transportation. Are we a plane or a ship? Our project is actually under the aviation cluster. That's why we are here. At that point, we didn't really know what we are doing. After the project started, we discovered that we are under the international maritime law, and we are considered as a ship, as long as we keep under the 150 meters height. And the key word is that interacting with the surface is what ground effect is in the end. Opa. Okay, thank you. Yeah, similarly to seaplanes, we are taking off and landing on the water, but flying later, keeping the low flight. This is a picture of one of the prototypes we built, 2 meters wingspan, that we were testing in a local swimming pool. What this also means that we can access easily areas without infrastructure, in case as well of some natural disasters or floods or volcano eruption. We can assist in case of emergency where the airplanes cannot go or the helicopters cannot go. Basically any area with water access or even ice. Where we're testing as well this prototype, this was in Lapland, in the very north in Finland, because actually the ice is a perfect environment for this because there are no waves. It's perfectly flat. And then in our case, we even had some snow on top. So for the first stages of testing, there is some cushion. So if we do have some crash, it's a bit softer. we ended up breaking it anyhow. So yeah, we got now.
Experiment though.
Yes, it's a research. It's a research. But yeah, we got some 2.5 of these planes for now. Autonomous operations. So as I mentioned, we're going to have kind of traditional sensors in robotics: the radar, lidar, stereo cameras, thermal cameras, GNSS, inertial navigation system, with the goal of obstacle avoidance, also detecting the waves, with remote control optional, because we do want to keep human in the loop. We don't want the vehicle deciding by itself where it goes. Seaworthiness is very important. So this was one of the kind of limitations of the ground effect vehicles. But however, nothing prevents these vehicles to fly higher. We can always, in case of rough and high seas, we can always fly higher. We lose the efficiency of the ground effect. The ideal, the optimal flying height is always more or less like 0.5 meter of wingspan. So if we are talking of a 10-meter craft, we should try to stay below 5 meters to maximize the ground effect. However, we can go higher. Also, the control system should be able to handle those rough seas. Where we want to use it, ideally, this highly depends, of course, on the wingspan. The bigger we go, the bigger ranges we can cover. What in this project we are focusing is the mid-range distances, Mediterranean islands, Canary Islands, Azores Islands, and transportation from between inter-island and as well from ship to ship and ship to ship for cargo transportation. Futures, in the project itself, we are designing the 5 meters wingspan. We have a commercial concept of 25, you will see it on the next slide, with the payload anything between 50 kilograms for the small one to 7 tons. This is the one here that we are going to build. The manufacturing is starting in following months. We are planning to demonstrate this next September, October in Canary Islands. And the commercial concept is what we use as a basis for the business cases analysis we are doing, which was designed taking into account of one shipping container. However, anything between this is basically possible. The big commercial concept is the payload of the 7 tons and some range of some hundreds. This is maybe a bit optimistic, but that's what we hope, but we don't really know at this stage. That's it. Thank you.
Time for one quick question.
Well done, thank you very much for that. One quick question. Considering the concept has been around for a long time, since the 1930s, and of course the Russians have done it, the Chinese have some wing-in-ground effect vehicles already. What do you feel is the biggest technological challenge or barrier right now in this project? Is it the sensor? Is it like the navigation, the sensor, the automation, or what part of it? Is it the aerodynamics? What is the most difficult part of the project?
Flying stably. Last week we had another round of tests, and we discovered again that all the CFD simulations we've been running for months are actually not saying almost anything. And we really don't know, we don't have enough, we cannot simulate the ground effect, which is quite a big problem. And we are now running and designing, testing it, then redesigning, testing it again, and achieving the stable flight. It seems to be at the moment the biggest obstacle what we are also experiencing and what the other projects were experiencing as well.
Is that because of the external parameters like wind gusts, waves variation, or is it because of the aerodynamics of the vehicle?
The aerodynamics in that low to the ground are very difficult to predict. It's something that we cannot, if you cannot run proper CFD simulations and properly design the plane, we don't know really what is happening.